Recall the intermediate value theorem. The intermediate value theorem talks about a continuous function on the closed interval AB. And it says that if f of A does not equal f of B, so these 2 points here are different, then if we draw a dotted line somewhere between f of A and f of B, and we call that n, then there's a point lying between A and B on the x-axis such that f of C is equal to n. This is quite useful for the following question. It's a pretty cool question. Show that at any given moment, there are 2 points on the Earth's equator that are directly opposite one another and have exactly the same temperature. So to start, let's draw a picture of the temperature on the equator. And now we're looking down from the North Pole. And so this is the North Pole right here. And so this arc here shows the equator. And theta is the angle. Okay, so 0 is here, and theta is the angle given there. And because we're interested in the temperatures on the opposite sides of the Earth, we can also put in T of theta plus pi. And so this angle there is theta plus pi. And to try to use the intermediate value theorem, we're going to create a difference between the two temperatures, T of theta and T of theta plus pi. And if we want the temperatures to be the same, then d of theta will be 0 for that value of theta. So we're going to consider d of 0 and d of pi. And we'll show that these have opposite signs. So d of 0 is going to be T of 0 minus T of theta. Now d of pi is going to be T of pi minus T of pi plus pi, which is equal to T of pi minus T of 2 pi. So 2 pi will just take us around the circle exactly once. And so this is equal to T of pi minus T of 0. And so this is going to equal minus d of 0. So if d of 0 is equal to 0, then we are done. Otherwise, if d of 0 is greater than 0, then d of pi is less than 0. Or, if d of 0 is less than 0, then d of pi must be greater than 0. In either case, d of theta switches sign either positive to negative or negative to positive. as theta goes from 0 to 2 pi. From 0 to pi, I should say. So if d switches from positive to negative, or from negative to positive, as theta goes from 0 to pi, then there is going to be a c that lies between 0 and pi, such that d of c is equal to 0. And so if d of c is equal to 0, then we have t of c minus t of c plus pi is equal to 0. And so t of c will equal t of c plus pi. Pretty cool, eh?